Hello and welcome to dear students into new video. In this video, we're going to solve some important problem from the past papers for quiz 2, which is coming from chapter 2 and 3. So in chapter 2, we learned kinematics in 1D, and in chapter 2, we learned kinematics in 2D and 3D. So we begin by chapter 2 problems, how to find velocity, how to find speed, and how to find the distance from the plot. And if the function is given to you, how could you find these quantities if from these two methods? So the problem we're going to solve. So if you know these problems, stop the video and solve the problem and then see the solution, so it will help you or boost your confidence and your concepts as well. And if you didn't know the concept, then you can see the solution and solve by yourself. So let's begin with the problems. Let me share my screen first. Okay, so here is the three problems we going to solve. First problem is a position time graph and how to find velocity, average speed, and distance from this information. Then how to find these things like velocity vector, position vector, if you are given by a function of x and y, and then how to use the equations of motion to solve these words problem. Okay, so let's begin our first problem. So these problems are from the past papers that has already been done. So this problem is a position time graph. So here on y-axis you have position, and on the x-axis you have time in seconds. So in meters and in seconds. Okay, so the first problem is a person derives a cart along a straight track. So it's a 1D problem. So the position of the cart changes over time as shown in the graph. So the position changes like this, and then like this, and then like this. So the time domain is from 0 to 3 seconds, and the position domain is from 0 to 50 meters. So what the question is, find the speed of the cart. So what is the speed? So speed is nothing but the velocity magnitude. So what is speed? Speed is nothing but the velocity magnitude, or you can say that speed is the total distance divided by the total time. This is speed. Okay, so how do we define the velocity? So velocity is nothing but the rate of change of displacement. Rate of change of displacement. And speed is the magnitude of that displacement. Then how do we find the speed from this graph? So he asks you to calculate the time at time t equals to 1 second. So he starts at this time and he wants us to calculate the speed at 1 second. So when he starts, its time began. So how do you find the velocity? Velocity from the position versus time graph. So you take a slope. So how do you take a slope between 2 points is nothing but y2 minus y1 over x2 minus x1. So in your case, your position we represented as x and your time is represented as t or t1, t2. So at 0 time, t1 equals to 0, and your position at that time is 40 meters. At time t2, which is 1 second, its position, so this is x1, so this is x2, which is at 1, its position is 20. Very good. So now what we going to take? So we're going to take a slope. So slope of this will give you the velocity. So slope will give you the velocity. So the slope of the velocity time graphs give you the velocity. So what is the velocity in that case? So velocity is x2 minus x1 divided by t2 minus t1. So what is your x2? It's 20. And what is your x1? This is 40. So what is your t2? So t2 is 1 and your t1 is 0. So what we get? So we get minus 20. So 1 minus 0 is 1. So we have 20 meter per second. So this is your velocity. So how could you find the velocity anytime you given a graph of position versus time? So you calculate the position at initial point and the final point on the position versus time plot and take a slope. So slope will give you slope of velocity slope of position versus time, graph of distance versus slope of position versus time graph gives velocity. But in the question, he asks you to calculate the speed. So what will be the speed? Speed is nothing but the magnitude of the velocity or mod value of the velocity. So what is the mod value of the velocity? Is 20 meter per second. Okay. Now, what is the average velocity? So whenever you calculating the average velocity, it has to be an interval. So this interval is given. So whenever you ask to calculate the average velocity, find a time interval and calculate the positions in these time interval. So average velocity is nothing but delta v delta x over delta t. So it's a vector quantity to change in displacement divided by time. So what is nothing but x2 minus x1 divided by t2 minus t1. So ask you to calculate t1 equals to 0. At t1 equals to 0, your position is 40. So your x1 is 40. And what is t2, which is 2.5? So here is 2.5. So 2.5, its position is 20. So at 2.5, x2 is nothing but 20. Okay. So, okay. Now calculate the velocity. So x2 is 20, x1 40, t2 2.5 minus 0. So you will, yeah. So your average velocity is minus 20 divided by 2.5. And when we do the calculations, we get minus 8 meter per second. Okay, so minus sign telling you the direction of the velocity. So it's a negative in the opposite direction because it starts from the higher position and now it's at lower position. So the displacement is negative. So the direction of the displacement is negative. So that's why the velocity is negative. Okay, next, how do you find the average speed? Average speed of the cart between t1 equals to 0 to t2 equals to 2.5. Average speed. So your average speed is nothing but the total distance divided by the total time. Okay, so the total distance divided by the total time. So what is the total distance traveled between 0 and 2.5? So we can calculate the total distance. So from this 40 to this 10, it's 1.5, and then from here to here. Okay, so what is the total distance? So the difference in the position 40 and at 4.1 is 10, and from 1.5 to 2.5 it's 10 minus 20. So the total distance is nothing but 40 minus 10, and when you take the magnitude plus 10 minus 20. Okay, so the total distance we get 30 plus 10, which we will get 40. So the distance has to be positive. So that's why we take the mod value. Okay, otherwise this will be negative. So the total distance has to be positive. What is the total time? So total time is 2.5. So what is your average speed? Total distance is 40 and total time is 2.5. So we will get 16 meter per second. So this is how you solve the position versus time graph. We can find the velocity and we take the magnitude of this velocity will give you the speed. Then we can calculate the average velocity and then average speed. Okay, now move to the next problem. So here we have the function. So if you are given by a function of like an x or like an y, how would you solve the problem related to this? Okay, great. So the coordinate of a bird flying in the xy plane, so it's a 2D problem, are given by the position x and position y. Find the x component and the y components of the velocity vector of the bird at t equals to 1 second. Velocity. So what is velocity? So if there is only one point, if you are calculating the only velocity at one point, so this has to be an instantaneous velocity. Instantaneous velocity. So what is your instantaneous velocity? Because when we in the previous problem we have found the average velocity. So average velocity has to be in interval of time. So instantaneous velocity is at a single point, the velocity at a particular instant, which is t equals to 1 second. So how do you find it? So instantaneous velocity is nothing but the dx dt or dy dt. So we take a first order derivative. So we take a first derivative. So in your calculus, you learn how to calculate the derivative. So x of t is given 2.5t, and we simply going to apply a power rule, which is nothing but dt t of power n. So what we get, we took the power in front and make a difference with the power n minus 1. So this is how we solve the derivative. So what is a derivative of t with respect to t is 1. And what is a derivative of t square is nothing but 2t. So here we have a derivative. So we're going to take the derivative dx by dt is nothing but 2.5. So this is a velocity component along x. Now, what is the velocity component along y? We're going to take a differentiation with respect to y with respect to t. So the constant has a derivative 0 minus 1.5. T square has a derivative 2t. So we will get 1.5 multiplied by 2, which is minus 3.0 t. This is dy by dt, which is nothing but the velocity component along the y. Sorry. So this is your y component of the velocity, and this is your x component of the velocity. So you can write a vector vxi plus vyj. So it will look like 2.5 along x and minus 3.0 along y. So for the part A, just solve this and this. Now we're going to substitute t equals to 1. So t equals to 1, t equals to 1. So your velocity vector Vx is Vx has no t, so it will be 2.5. And here you substitute 1, which is nothing but 3.0. So this is the answer of first part. Now find the x and y components of the average velocity vector between t1 and t t0 and t1. So whenever we find the average velocity, we also having an interval. So average velocity, v average, is rate of change of displacement, which is nothing but x2 minus x1 divided by t2 minus t1. So this is one dimensional. Now we have the average velocity vector. So we're going to find the velocity in x direction and then velocity at y direction. So what is x of t, which is 2.5t? So what is t1 equals to 0? So your x1 is 0. So what is your x2? The function of at 1, which is 2.5. Okay, so your velocity along x is nothing but x2 minus x1, t2, which is t2, t2 is 1. So your x2 minus x1 divided by t2 minus t1, which is nothing but 2.5 minus 0, 1 minus 0. So you will get a 0.1. So this is your velocity vector, average velocity along x. Similarly, we can find velocity along the y. So we average along y is nothing but delta y over delta t, which is y2 minus y1, t2 minus t1. Okay, so what is our y? So our y function is given here, 3 minus 1.5. So y is 3 minus 1.5 t squared. So at t1 equals to 0, your y1 is, when you substitute t equals to 0, so this value is 0, so you only get 3. So what is your t2? T2 is t1. So 1 second. So 1 second. So y2 is 3 minus 1.5, 1 squared. So you will get 1 squared is 1 multiplied by 1.5. 1.5, so 3 minus 1.5 is 1.5. So this is your y2. Okay, this is your y1. So you just substitute over here. So 1.5 minus 3, 1.5 minus 3, which is 1 minus 0. So you will get minus 1.5 meter per second. So this is your velocity, average velocity along y. This is average velocity along y, and meter per second along x. Okay, good. So you can write a velocity vector, which is vxi plus vyj, which is nothing but 2.5 I minus 1.5 j. So if you ask to calculate the speed, so speed is nothing but the magnitude of the velocity, which could be calculated as vx squared, vy squared. So just substitute the value of vx and vy and take a square root. So you will get the velocity. So this is how can you find the velocity if the function is given. Okay, now move to the next problem, which is rather very simple, and we're going to use the equations of motions. So what are the equations of motion? So here are 4 equations of motion we're going to use. Okay, so what color I use? So I will use like blue color. So your first equation of motion is the final velocity is equals to the initial velocity plus the acceleration into time. Your second equation of motion, this is along 1D, or we can generalize it 2D and 3D. So along x or along y, so you can write it x. So this is your along initial position, then v naught of xt plus 1 half, sorry, at squared. And the third equation of motion is vx squared is nothing but v naught of x plus 2a x. And the fourth equation, this is 1, 2, 3, and the fourth equation is the distance x, which is the average velocity vx, v naught of x divided by 2 into time. Okay, so what we're going to use this equation for this problem, which is a dog is moving with a constant acceleration. So these equations of motion are derived with the assumption that the acceleration is constant. So on a line between the 2 points, it starts from rest. So this is the information, which means that v naught of x is 0. So initial velocity is 0. Okay. Then covers a distance of 70 meters. So covers a distance of 70 meter. So this is your x, y. You can say that x along the line. So this is x. So in time, t second. Okay. So, okay. So what we have, the initial velocity along x is 0. Your total distance is 70 and your time is 8 seconds. This 0 meter per second. So this is given in this question. What he is asking you to calculate the acceleration. So we can calculate acceleration from here or from here if we know the initial velocity, the final velocity, and a time. So we have initial velocity and we have a time, but we don't have this final velocity. Okay. So, or we can use this equation of motion. So we can use this equation of motion to calculate the the acceleration, because we starting with the initial position x equals to 0, then we can have vx naught, and then we have t, so we can find it. So we can use the second equation of motion, which is x equals to x naught plus v naught of xt plus 1 half at squared. So this term goes to 0. V naught of x is 0. So this term goes to 0. So you're left with x equals to 1 half at squared. And your a just rearranges multiply by 2, 2 multiplied by x divided by t squared. Okay, so when you substitute the values over here, so values over here, so you will get the acceleration. So 2 multiplied by 70 divided by 8 squared, we get acceleration, which is, I think, 2.19 meter per second squared. So this is the acceleration we get. Now, what is the its speed at the second point? So he's asking you to calculate the final speed. So we will use this formula. Acceleration is Vx minus V naught of x t, and we can arrange it like equation of motion V naught of x plus at. So this is 0. So will become at. So Vx is 2.19 multiplied by 8. So you will get 17.5 meter per second. So in this video, we have solved 3 important problems. So try to practice it, and I'll meet you in the next video with the next problem. And best of luck for the quiz. See you in the next video. Bye bye.